Hello, anybody who may be watching, my following of 30 or so subscribers, whether or not they're active or not, I appreciate when I do get interactions or likes or just views, just people watching what I'm working on. I have an update video. So I did not so to try to make it quick, I got rejected from a healthcare job. And you may ask, well, why would you waste time and money on a master's in bioinformatics just to pivot careers immediately after your degree? Well, a couple reasons, but the main one is, well, I did structural bioinformatics, which is along the lines of material science or biomaterial science with lamps. And you can search far and wide, unless you're a PhD baby, like a sort of like a Nepo baby of the academia, you're not going to find any opportunities with molecular dynamics that are at least in Philadelphia. I mean, it's not something you can just find like you can find an omics job or genomics job. So with that said, I'll get into that, but the other reason was I believe in I call me a dreamer, but I believe that you can coalesce ideas and skill sets and make use and then go into healthcare and be able to like network your way into a perhaps software role where you're still working with informatics. It's just neuroinformatics now. So there's that. And but it doesn't matter because it didn't work out. This is the third time I've been rejected by this company. So maybe I should take the hint, right? And I will. And I love the company. They're good, interesting work, but it's just not for me. So with that said, what do I do now? 5 months out of a master's degree in bioinformatics at Temple University. I need to make use of this, right? Immediately. So what I decided was instead of trying to double down on structural bioinformatics, which I'm not, against, I love molecular dynamic simulations. I wish I had HPC access more available to me, and also more conceptual and mathematical expertise, like, more dynamical systems math and numerical methods math. I don't have all that at the moment. What I decided was, well, screw it. I will learn to love omics and genomics and transcriptomics, especially. The last one, especially. Why would I be interested? Because, well, not only is it industry critical, people want these omics jobs, but I also find this real deep fascination with how we're how we're integrating spatial processing into or spatial data analysis into transcriptomics, RNA sequence, bulk RNA-seq. It seems like there's a lot of methods to do it. I believe there's something called pixel-wise and stereo sequence to stereo, meaning stereo graphic, like 2.5 atom resolution or something like that, or angstrom. And then you have going deeper, you wonder like, okay, can I use image processing and AI to approximate what a single atom resolution, or excuse me, I keep saying atom, I mean cell, single cell resolution would look like in a in a model. Um, it's also there's also a lot of interesting stuff going on right now in the field of biotech and AI that is so beyond simple bioinformatics. I hate to say like downplay bioinformatics because it's such a pivotal and foundational role, but there's a company that fellow Philadelphians started, Mishra, started Preci Genetics. This is a live cell recording company, which will definitely revolutionize several different fields at once, including bioinformatics and how we and transcriptomics, because they are an epigenomic focused company. There's also epigenomics, right? I studied with Dr. Lee for a short period of time at Fox Chase Cancer Center. And, I still have that data. I'm not going to give it out because it's not mine, right? But I'm going to definitely use it to do some exploratory data analysis. And it's basically to go back and bring it all back. The main idea is to hit every omics, basically transcriptomics, epigenomics, genomics. The genomics, of course, is the most important because that's NGS, right? Your next generation sequencing. If I don't have that type of skill set where I can run a pipeline and automate a pipeline and generalize a pipeline and build my own integrated system, basically in the long run, I'm not going to have the confidence to run pipelines and maintain pipelines when I get a opportunity in the omics field. Also, you can't do spatial transcriptomics without having NGS knowledge. So with that, all that said, we're pretty much. I maybe just as a last aside, like beyond the OpenAI schlop, like Sora 2, there's a lot of interesting stuff going on right now in biology and AI. There's a virtual cell project. There's Preci Genetics. There's they're mixing different transcriptomic methods to get these full 3D models or imaging of fallopian tubes recently. Uh, the you know I'm both interested in the research problem and also the techniques used to the methods used to solve the problem. So methodology and basically, for example, like oncology, n neurodegenerative disorders are still interesting to me. And I guess that's pretty much all I wanted to say. Um, yeah, as an aside, a final aside, I didn't know that BlackRock had a neurotech company that's been 20 years active, long before Neuralink, which is interesting. The not silver lining, but common thread between bioinformatics and neural cybernetics is signal processing and encoding and decoding and alignment of data. Just like you align different waveforms, you would align different base pairs, nucleotides. So yeah, to just to really hyper focus, I have it here actually, and I'll post maybe my GitHub. I also may consider streaming this stuff, like to maybe motivate me if I get a better webcam on my other computer. But basically, I would stream core next generation sequencing knowledge, like learning FastQ and handling quality control with multi QC or fast QC using Trim-O-Matic, Trim Galore, or Cut Adapt to do adapter removal, master alignment to reference genomes, with the I think it's Buller BWA MEM. I forget what it's Burris Wheeler algorithm. I'm not sure. SAM tools as well. And this is basic, right? This should have been taught to you in school, right? And I'm not gonna play that card. It was taught, but I didn't understand it at the time. So now I'm going back to make sure I understand it. I pick structural. We don't use pipelines like this, at least not at my level. I didn't. Variant calling with GATK, a haplotype caller, or BQSR. Then around the 3 month 4, I guess I would say I would do RNA sequencing introduction with Salmon, Callisto, Star for quantification in bulk, expression matrices for differential expression in DSeq or EDGE-R, enrichment and pathway analysis with cluster profile or GSEA, and hone in on single cell in month 6. Um, and then finally in month 7 to 9, let's say, I would get into tissue mapped RNA sequencing with 10x Space Ranger, Seurat Spatial, SquidPy. So basically, you see what I did. I just asked language model what I would need to succeed in industry with no background in NGS and no background in spatial transcriptomics, and that's the answer I got. So with all that said, I think this is a proper update video. If you're curious, doesn't really matter, but I am doing well. I think as long as my well-being is modulating a good amount of efficiency, the goal is still to get a career. It's really not, it's really more about that. There's so much fruit with Pressy Genetics and other companies starting up now and spinoffs that it makes sense to dream big. I'm not saying I want to start a startup, but would it be cool to be a bioinformatician for Pressy Genetics? Yes. And I've been sending it to some friends in hopes that they get opportunities with them. And I hope they do because they're good scientists and they deserve it. But anyway, thank you for watching.